Write the fifth term of 2x plus 3 to the power of 8. Write your answer in the form a times b times c times x to the power of d, where a, b, c, d is an element of the integers. So first things first, let's go ahead and write out our general term formula. Remember that this one is not in your formula booklet, so you do have to have this memorized. Now, I always find it helpful to list out what our known values are. So we know that the first term is 2x, the second term is 3, and the value of n, or the power of our binomial, is 8. From here, we're asked to find the fifth term, which means our r value must be 4, since our formula has t sub r plus 1. So now plugging in all our knowns, here's what we get. Since this is a paper 1 question, which means we can't use our calculators, we do need this formula to find n choose r or 8 choose 4 in our case. So we can rewrite 8 factorial as 8 times 7 times 6 times 5 times 4 factorial, which allows us to cancel out 4 factorial in the numerator and in the denominator. I've rewritten the second 4 factorial as 4 times 3 times 2 times 1, allowing us a few further cancellations. From here, we can find that our answer to 8 choose 4 factorial is going to be 70, because we're left with 2 times 7 times 5 in the numerator. We can go ahead and continue to simplify our expression. Okay, note that all of this work that I'm doing to find 8 choose 4 is on the side. We want to make our work really well communicated for the marker or the examiner to be able to follow along in our solution in a very clear manner. So 8 choose 4 gives us 70. Then we simplify the 8 minus 4 in the exponent to be 4, and 3 to the power 4 is 81. We can continue to expand the expression in the brackets, giving us 16 times x to the power 4. And then now the last step is just to rewrite our expression so that it is in the form that is provided. And we are done. Now, how would an examiner mark this question? They'll likely assign you a method mark for recognizing that we need to use a general term formula and for figuring out the value of r correctly. Then a final A1 for your answer. Our next question is as follows. Consider the binomial expansion x plus 1 to the power of 7, which gives us x to the power of 7 plus a times x to the power of 6 plus b times x to the power of 5 plus 35x to the power of 4, and so on until we get to 1. We know that x cannot be 0, and a and b are both an element of the positive integers. The first question is, how many terms are there in the expansion? Well, it turns out that in any binomial expansion, the number of terms is always one more than the value of n, or the degree of our binomial. So here, our n value is 7, meaning that there are 8 terms in our binomial. So that is just simply an accuracy point. So part B is a show that question. We need to show that b is equal to 21. You'll notice that b appears in the third term of this binomial expansion. Now, whenever we have a show that question, which basically gives us the answer already, we have to show our work very, very clearly, and we often need many lines of work to demonstrate that we understand how to arrive at the answer. It is not enough to just say that b is equal to 21. We have to demonstrate that we understand why it is equal to 21. So knowing that this b appears in the third term of our binomial expansion, we can set b times x to the power of 5 equal to t sub 3. And here's just a quick reminder of the general term formula. Now, if we are looking for t sub 3, we know that the r value must then be 2. And again, it is helpful to write out the other known values. So let's go ahead in our next line to continue this show that question and set b times x to the power of 5 equal to 7 choose 2 times x to the power of 7 minus 2 times 1 to the power of 2, using that general term formula. We continue to simplify. Now, really, it is important to show your work within each line, not separately on the side, because this is a question that requires a more involved proof. So We replace 7, choose 2 with our combinatorics formula. We simplify, okay, showing all our steps in detail. We want to demonstrate to the examiner or the marker of this question that we actually know how to apply and use this formula. So you must have it demonstrated on your test paper. Okay, so we simplify from here and we get a result of 21, and therefore B is equal to 21. So we have shown through a very rigorous set of workings, communicated step by step in each line, that B is 21, and we're done. So how would an examiner grade this question? Usually there's a method mark for identifying the correct term. Then there is an accuracy point for showing correct working somewhere. And then of course you need to actually state the final answer. So AG stands for answer given. The second last question in this set is write down the value of A. All right, so we know that A is in the second term of this binomial expansion, meaning that the R value is 1. So if I'm applying that general term formula again, I know that A corresponds to 7, choose 1, which is 7. Okay, this is a 1-mark question, so we actually don't need to show a ton of work. We just need to state the answer. The final question in this set, the third term in the expansion is the mean of the second term and the fourth term in the expansion. Find the possible values of X. Okay, there's a lot going on in this question. Let's break it down. We have the third term, we have mean, second term, and fourth term. So let's go ahead and list out all of these things. The third term is 21 times x to the power 5, as we found in part B. The second term is 7x to the power of 6. Okay, we found the value of A earlier to be 7. The fourth term is already given. It's 35 times x to the power of 4. Now, if I combine all of these things together, I know that the third term is equal to the mean of the second and fourth term. The mean is another word for summing, taking the sum of the two terms and dividing by the number of terms. In this case, there's 2 of them. So I add the second and the fourth terms, I divide by 2. Now we have an equation where we can solve for x. So let's multiply both sides of this equation by 2, giving us 42 times x to the power 5 equals 7x to the power of 6 plus 35 times x to the power of 4. Because we know that x cannot be 0, this allows us to divide both sides of the equation by 7x to the power of 4. That's our greatest common factor. Notice that all of these coefficients are divisible by 7, and we can also take out x to the power of 4 from both sides. Now, it's really important here that you don't write one giant division symbol and then just put 7x to the power of 4 underneath it. That is a huge pet peeve of math teachers. You need to actually show the division across both sides separately. You cannot divide across the equal sign. That does not make any sense, and you will lose preciseness in your communication. Okay, so from here, let's simplify. Now we have a quadratic, and we can set the quadratic equal to 0, and we can see that it's actually factorable. So we can factor this quadratic and figure out the values of x that would make this equation true. How would an examiner mark this? All right, so there's going to be a method point for attempting to set up your equation, an accuracy point for setting it up correctly. Then we have an accuracy point for getting your equation correct equal to 0. The equal to 0 is important because here, in order to solve for something, we need to have an equation. If you just have an expression there, that is wrong. Okay, we cannot solve for x unless the equal sign is there. And then finally, we have a method point for an attempt to solve your quadratic, whether or not it's factoring or maybe using the quadratic formula. And then a final accuracy point for your answer. This brings us to our last question, and we're going to save it for the next video.